So there are two folders available over here. This is a basic demo, and then we have a data. Okay, so this sheet contain all about the basics of that image processing. Although it's a basic, but if we build up a Python based GUI interface, then we can build up make a machine learning tool uh, for that also. Okay, so we can build up a tool if we use Python based GUI programming, and then we will integrate that code in the backend, and then this will do all the things for you people. So in this way we can make a particular tool out of these cheat sheets, that the sheets that are available over here also. So you can download it on your systems, and later on, or by the when we are doing this live demo over here, you can perform or at that particular time also. So over here, these are the images, and these are two sheets. I have inserted that particular software also. Then I have dictated the write down. I have uploaded the code for the conversion of all the images also, because when we have a lots of data set are available that is in the form of GBs, so it is not possible to convert that thing in a one go. So we need a computer based program for that to process that data, and it will take depend on your machine size and uh, your computational power also. So for that, which the model which I have trained, the data set I have approximately 60 GB or 65 GB of data. So I have processed that particular data through a MATLAB code, or through a DICOM, that particular software also. So, and then this folder contains a small data set. We have images of I think 32,000 total data set of images, but I have incorporated approximately 500 images, because it is not possible to upload all the data over here. Then this is a folder that contains the images which contain the positive results. And then there is a one model available over here. So these are the uh, models that we have built up, but later on we will build up other model also which will predict that particular disease. And then these are the sheets through which I will be dictating that how the things will work. So coming to the demo part, so I will start that Anaconda. So, so I will type here a Jupyter notebook. This is one way to open your Jupyter notebook, and the particular you go to that particular folder and type here Jupyter notebook. It will directly open that particular notebook for you people. And when we uh, see over here, so it shows that the sheet one. So this is a basic. These two sheets contain basics of that how the image processing will look like, and how the image segmentation will do. So I have a data mix up of data for the building up a machine learning model. I have herd related data. Then I have a for to demonstrate this sheets. We have a chest related data. So then I have one tumor segmentation related data also, which I will dictate in that one lab sheet also. You can you can you can use your own data set, and you can use these code to perform your analysis on your own research problem. Whether you are suppose you are working on the disease, just like as Alzheimer disease, then you can work you can the same code will work on that disease also. If you are working on that, if you have a data set of related to the kidney stone identification, then the same data set will work over there also. If you are working on the neural some type of neuroimaging data set, some type of specific data set, then this same thing will work over there also. If we are working on special type of diseases like as a leaf identification disease, or any type of related to agriculture part, or related to the biomedical part, then this thing will work over there also. So, this is the we have what we have done over there, that I have imported one one library. This is the image IO, and it's the version 2. So previously it's available version 1. Now it's the version 2. So when we click over there, so what we have done over here, we have a load our data set. So over here, I have a data set. So this one is our data set. That is, I have dictated that we have a DICOM file format. So I have a DICOM related file format. So I have a DICOM related format which is in a DCM format. So we have to use over here that GPG images. So how to process these JPG images available over here. So when I click it over here, so it is saying that we have import the library, and then it's your data is getting loaded. So over here I have one image and it will get it uploaded. Now we want to check the basic property of that particular image, that what are the basic property of the image which we have loaded. So we have to use this, we have to print the shape of that image. So what we have done, we have printed the image. So over here we have a 512 cross 512 image. So then if you have to check there are some metadata that is also associated with that particular image, just like as X-ray, CT scan, or MRI. So being a biomedical domain expert, you should know these things. If you are working on this domain, or if you are doing your research work, then you should know that particular metadata, that what type of data your image contains. So if we have to check for the metadata, then we have imported that particular image, and then we have to type out print and dot metadata and dot. So if we have done this, then it will contain all the metadata that is associated with your image that contains. And then if you have to plot that histogram of that particular image, that where your the color intensity will be different, so we have to plot the image plotting also. So for that we have to use that, we have to read our data, and then we have to convert it into grayscale. If we have to convert into grayscale, or we have to convert into black and white image, then it will give us a much more information. So as we can see that we have MRI images, we have a CT scan images. So they have in black and white domain. So we have to look for the enhancement, or we have to, if we have to look much more information related to the particular image, then we have to convert into grayscale, or we have to convert it into black and white image. We have to change the intensity of that particular image, so that we can get much more information. Over here we can see that that this image contains these tissues and these another information. But over here, when we see in the bottom, we will see that it contains another data also. So we will segregate that how it will look like. Then we have a draw image. Then so we can check the height and width of that particular image. So it is showing us that how it will look like. Then we will have to remove the x-axis and y-axis of that. So over here it is showing that x-axis, what is the height, and what is the width of that particular image. So if we have to remove, then we can remove that with the help of this command. So it's basically plot.image.show. So it is showing in a grayscale color, and then mean value and a maximum value. So we can, over here we can change our values also, just like as a 250, and we can get a different timestamps. So over here we are getting the different timestamps related to that particular image. Then comes to we have to look into when a radiologist or a researcher look for the images, then it has to deal with the multiple images. So in a particular scenario where you have to read the multiple images from a particular data set. So this data set contains almost I think 2,500 images, but I have put a few images to demonstrate this demo. So we have to use this type of code where we will use, or if we have to analyze 4 or 5 images from that particular data set, then how we can do this? So we can do with the help of this small code where we have import the image IO, and then we will use one library called as numpy, and then we will import these images. So over here, so these are the images. So these are the images that are available over here. So just 20, 21, 22, 23, 24, 25. So these are the images I have used. So it is showing that dimension of volume is 3, and it's a 512 cross 512. Then we can load these images over here. Here our images get loaded up. So we have to load these images and we have to analyze these images. So this small, a single line of code will do this work for you, and you can load all the images available over here. Then we can generate the subplots for that particular image. If we have to look for that particular image, that okay, so these are the plots that are available over here. So we will use that particular library, that matplotlib and pyplot, and then and it is showing the x-axis and y-axis. So we are giving, it is giving us the particular output for that image. Now, if we have to look for the sliced, or we have to look for the other views, just like as if we want to look for the smallest part and we want to trace it out for our research work, or we want to look a particular part in within our image, then we have to do, and then we will select a particular part over here, and then we can enter, and then it's showing us a sliced window of that particular image. So what is happening over here? We can make the changes. It's like as if we want to 100 cross 100. So it is giving us some sliced window over here. Now your position of your particular image has changed. So through this particular sheet, we can do the little bit of modification, and we can analyze the basic property of our image. So this is a simple lab sheet, but it really helps you out when we have to deal with the biomedical image analysis in the real time, or when we are analyzing, when we get the data from the sources, from the hospitals or other sources. So it will help you out to analyze the basic, to do the basic analysis. Then comes to the, so over here we can get much more information related to our particular image. So over here what I have done is I have imported the libraries image IO. So this is one is new one. Everyone is famous about this numpy and matplotlib and numpy. So this one is new. So this is basically deal with the biomedical image, and to do the biomedical image or to read the images, then this library, specific library, has designed to perform that particular task. So what we have done, I have imported these libraries, and then I have created one functions, so through which we will call all these values, and then when we click it over here, so this function will, so we will getting the data related to this, like what is the data type, then what is the mean value and what is the max value of that particular image. So you can use over here, I have used that MRI image. You can use over here this, like as I have a hand dot X-ray image. If we have another image, then you can use over here according to your own requirement. You can use your own image, and then you can look the same properties for that, and then we can draw the histogram, that which shows that the color distribution of our image, that how the color will be distributed in that particular image. So through this, we will draw a histogram. Over here, we can set minimum values and the maximum values, just like as a 200 or 200, then mean value is just like as a 150. So it will depend on your requirement, and we can get the histograms. So over here we can see that our values get changed. So when we learn some basics of image processing, then we will know this, that how the color distribution scheme will work and how it will affect our images. So over here, the histogram. So through this histogram, we can get our information related to our image, and this would really help to diagnose the to diagnose if there is an alteration in our image. Just like as for the forensic science, this will also help for the histogram images. So what they have done is, let us suppose they have to identify identify the identify the false signatures, or there is a tampering in the signatures. Then this could also help over there, because if there is a tampering in that particular section, if there is a false signature is available over here, then it is showing the different histograms as compared to previous one. So this might be the one applications of that histogram. Then we can do the masking also. So to do this masking, it is giving us a masked value of that our particular image. Then, so these are the some basic sheets that and basic analysis that could help you out to understand the basics of your data sets. So if someone is beginner over here for the for the image processing and machine learning, directly related to the image part, so these sheets will help them out. Now comes to the machine learning part. So how the machine learning will work over on that particular image data sets. So we have learned over here that how the how to how to load the images and the how to get the basic information of data related to the machine learning model. If we have a data, then so this one folder contains all the data sets related to the image processing. So if we open that particular one sheet, so over here, to develop a basic model, just to tell the uh, uh, to tell that how the machine learning model will work. So I have used that there is a one famous data set called as MINIST data set, on which I have worked to demonstrate to that how the model will work and how the testing and training will work, and then we will move to the herd images, and then the tissue segmentation images also. So this sheets contains all the basic demo of your machine learning model. If we have to build up a basic machine learning model which has a least accuracy, and just to test it out that how the model will work. So we have to import. So over here, I have import the TensorFlow and the Keras libraries that are available over here. So this line will import all the libraries, and then let's suppose we have to check what is the version that is installed on your particular computer, because we have lots of environment. Some code is working on different environments, some code is working on different environments. So if we have to check the different version that are installed on your system, so this simple command will help you out over here, and then it will showing that okay, this one is the version of TensorFlow that is installed on your data sets. So over here, now coming to the next sheet. So it is showing that we have to load our data set. So there are two ways. Either you have a data set on your standalone computer, then you can load in a different way, but you can load it directly also. from the server, and you can directly call it. So we can load over here data set. So uh, um, this command will load your data set, and uh, it will divide into x test set, and then y test, and then x train and y train also. So uh, so when we have load our data set, so I have loaded this data set on my system, so it is getting completed within a few seconds. And I have machines of 16 GB RAM and i7 based processor, so it's a latest processor, so it is taking less time. But when you will perform this on your own machines, then it will taking some times to load your data set, and it will download that particular data set, and then uh, uh, it is uh, uh, it is taking some time. So when we have to check that, okay, so we have loaded our data set or not, so we want to check one uh, particular point or particular image, that okay, so we have loaded our data set or not. So we will use this. So it is showing that okay, we have loaded our data set, and all the data sets will be uploaded. Now we want to check that our data set is how it will look like. So for that we will use that library, which is called as matplotlib. So through which we will check uh, our data, and it will contain the binaries values. So MNIST data is famous data related to the handwritten, related to the digits which contains 1 to 9. So if we will show, then it is showing us some value. Okay, so it is some value like a 7 or 3. So it is giving us a value. Just like as if we will use over here array 1, then it is giving us a different value. If we have used 2 over here, then it is giving us a different value. So we will use over here just like as a 0, because we have loaded over here frame. Then, so what is available over here at the 0th location is a 5. And then we will normalize our data. So what does it mean? That some of the data would be, some of the images would be in the bigger format, some of would be in the uh, some of the images would be at a lower, they have a different pixel image. If we look to this data set, let me, so this is the data set. Okay, so it has a different shape and size. So it will normalize that particular data depending on your requirement. So so when we click it over here, it is doing that thing for you, and it will normalize your data between 0 and 1 values, or it would be -1, or so it would be depend on our requirement, that negative is for the uh, it would be -1 and a +1 also. So then we will again look into data, and we will see that over here it's showing different values, but over here it's showing 0 and 1 value basically, or our data get normalized. So it is very much important when we are dealing with the real-time images, or we will get our data, then we have to normalize it first, and then we have to show that particular image. So it is showing us a different. So now this is our normalized image. So it is showing us a normalized value, normalized image. Then we have to build up a machine learning model, simple deep learning model, where we have used TensorFlow and Keras. So we have used that sequential. So our model would be sequential, and all the layers would be flattened. So I have dictated this in the last lecture, that what are these fully connected layer things, and that what is the flattened layer mean. So this is a one layer architecture. Then we have used the activation functions. So we have a different type of activation functions. So over here we have a relu activation function. Then we have a damage activation function. We have a binary activation function also. So it will depend on our architecture and what type of analysis we want to perform. So over here now we are using a dense 128 uh, layer architecture to uh, perform our to run our a simple deep learning model. Then we will add another layer. So it will our layers will be getting add up. So over here we can add one more layer also. So what you have to do, we have to go to over here and insert and cell below. So what is happening over here? A new cell will be added over here, and then we can just copy and then paste it over here. So your new layer will be added, and then you can change over here also, just like a relu. I have used the activation function relu also. Then we are getting our output. So so generally we can use generally we will use that as relu also. Then in the end we will use softmax to get our output, and then we will use to compile our model. There is a optimizer called as Adam, and then we will use that loss function. For the loss function we will use sparse categorical cross entropy, and then we will calculate the accuracy also. So when we compile this our uh, our model over here, then over here it will deciding that how many epochs we want, and how our model will work. So over here there is a one function called as model.fit. So through this we can run our machine learning model, and we can run number of epochs depend on our requirements. So for the demo purpose, I have inserted only 3 epochs over here. We can change also. So for the heart disease model which I have run over here, so I have run 100 of epochs, and then we can use the optimizer also, Adam also. Then we can use the loss function over here also. So uh, so generally when we are doing the research, we have seen that we have the same data and we are getting the different outputs. So on the same data, what the research community will be doing that they are changing this particular architectures. So when we add one more layer, then we are getting a different output. If we add over here, if suppose we will change to relu to softmax, then we are getting different output. If we are getting change relu to this like a leaky relu, then we are getting a different output. So on the same data, we can perform a n number of analysis, and we can make a make and publish these paper out of these networks, and then we can do the comparative analysis on that particular same data set, or we can take the 2 or 3 data sets, and then we can do the comparative analysis over here also, and then we are getting the different outputs, and we can analyze our results. So the which one is better for our research, and to pursue more to carry forward our research work. Then uh, uh, then after doing the epochs, we have to print out our that what is the validation accuracy, and what is the loss. So over here we can see that it is showing us that a loss is minimized, and our loss is getting minimized, and accuracy is 96%. So although it's a good accuracy, but we have used a little chunk of our data, and we will use 3 epochs only. So if we will change 5 to 5 epochs, then we are getting a different accuracy. So we are getting a different accuracy, and then we will run this particular code, and then we have a different output. So this thing is a hit and trial method, and we have to stick to into this, and then we will when we will run this particular pipeline for 5-6 times on different uh, while doing different tuning in our data set, then we are getting a better accuracy, and then we will come to know that okay, this one is performed better, and we will use that particular model to carry out to do the analysis. So over here, our 5 epochs will be completed. So when now we will see, if we look into this, then we are getting 97% accuracy. Previously we have a 96%. Now it is getting a 97%. So now comes so over here till up to that, this is a typical machine learning part over here till we are building our model and we are getting accuracy and we are predicting, we are getting. Now comes to the part where we have to save our model. So what we will do, we will train our data, we will test our data, and we will predict, okay, so this one is accuracy on our data set. Now what next? So we have to save our model. So the simple function is model.save, and we will save it through a particular name and with the extension of a dot model. So your model is getting saved. So we can see that we can just change this workshop underscore demo. So now if we see, so we will see over here that we are getting 2 models. So this one is showing us different workshop demos. So this one is showing workshop demo. This one is the model, and there is one model epic num. So we are getting 2 new folders. So in this way, your new folder will be created, and your model is getting saved up on our standalone system. But if you are working this on, if you are running this code on that Google Colab, then it is saved over there also. But for the heavy extensive work, if we have to build up good models, then we have to do our work on the standalone systems. But yes, Google Colab is also helpful for doing some tasks which require less number of time, because it has I think it will get updated after 24 hours. So all the values get depleted, all the values are missing over here. So if you are working on such type of model which are taking less time, then you should go with Google Colab. And otherwise, if you are working on heavy extensive models, then you have to use that GCP console to train your model, or if you have high-end workstations, then you can do over there also. But yes, if for the minimum to run this particular model or to do good research, at least you should have 16 GB of RAM on your system, so that this is run smoothly on your it will run without disturbing or without hanging. So now comes to the new model. So over here, what we will do, we will our model is getting saved. Now we have to make the predictions. So we will make one variable new model, and then we will use that particular code, that tf.keras and model, and then we will load our model. Okay. So when we load our model, so I have made this epic num reader model, and we will load it. So with this particular line, our model is getting loaded up. Now what we have to do, we have to make a predictions, because we have trained our data set available over here, and then how it will look like, and how it is. I'm sorry. So we are over here. So we have to make predictions. So how to make predictions? So we have to load our model which we have saved, and then we have to make predictions. So what is doing? It is loading that particular weights which we have, or particular models which we have trained earlier over here, and then it is making us for the prediction. So now we have to look for the predictions that what are the predictions our model has make. So we have to see. So this is a numeric value, and we are not able to see that what the prediction here our model has made. Then this is the output. Okay, so this is showing us the output, and then these are the final predictions which will made by our machine learning model when we do that when we use that particular saved model. If we have used that workshop underscore demo model, then let's check that what workshop. Then I think I have typed. We will use that particular model. So it is showing us the prediction, and then we have to look into that. Okay, so what are the predictions they have made? So over here it is showing us that our model has predicted 2. Now we have to visualize that. So this one is, so we have to visualize that particular image also. So what the image will be contained on that X test set. So we have to use this code, and it is showing us a 2. So this is the simplest machine learning model. So while building up your deep learning network, this type of uh, methodology will be work, and we are going to build up our machine learning model for the heart disease, for the brain tumor, for the kidney stone, for the leaf disease detections, then for the object recognitions. So there is some type of variations that is takes place over here, and rest all the things will be same if we have image related data. So this one is one sheet. Now comes to the second sheet which I have right now. So there is a one more sheet which I have prepared related to the image segmentation. This one is a simple sheet. It's not running a neural network, but yes, it is showing us that how we can perform the uh, the uh, uh, image segmentations. So let me clear all the outputs first. So we will, if we have to clear that particular model, then we have to go to our kernel and then restart and clear output. So it is over here, it is getting all the outputs are getting cleared up. So what we have to do, we have to import all the libraries. So over here, I have used SK image, which convert from RGB to gray. So over here, we have to use we have to convert our images from RGB. If we have a color images, then we have to use it in a gray. And if we have, so this library will do that for us. Then we have a numpy, CV2, all the same basic library which we have used. Then we have loaded our image, which is heart.image. So it is present on that particular folder. So this one is the image which is presented over here. So it is getting loaded up. Now we will see that particular dimensions which I have shown earlier. Now we want to convert that particular image to grayscale. So it is not giving us so much more info because already it has in the form of black and white. So now we want to calculate the shapes. So it is showing us that it's cross 194 cross 29259, and then so it is so this line of code, what is happening over here, we are reshaping the image, and then it is getting converted to the grayscale. So this is our image. So over here, we are getting a different information, just like as suppose we have a blockage available over here at that particular area or that particular area, and we want to check that and this area is infected. So it is over here, it is not visible. But if we apply a simple this 2 lines of code and apply one button through the Python GUI library, and it will convert to grayscale to that black and white to grayscale, then it is giving us much more information about our data set. So we are getting more information. Then we have to look for the edge detections, that what are the edges that are available. So again, we will load this particular image, and then we will convert this image. So this will showing us that if we will convert this image, then we will put this image horizontal and vertical into the arrays, and then we will process it. And then this simple line of code will giving us the values in the form of edge detection. So we are over here, we are getting the different edges. So over here, it is showing us only the edges of our image. So this is a very poor example, but when we will work on image data set, then after spending 5-6 hours or 10 hours, 1-2 days, then we can improve that edge detection method also, and then we will use the image capturing and image enhancement techniques, and we can develop a tool for that also. Then we will convert into that grayscale. So this is not giving us any impact. I will give one more demo on particular image. Over here, you will see that it will give us a different output. Then we will look into the clustering. So how the clustering will perform based on the segmentation. So we have imported our libraries, and then we have used our image. And what I have to do, we have to show that image, and then it is converted to black and white to RGB. So over here, it is not getting giving us much more effect. So I will running code simple, and then over here okay, I want to point out that how many k means center. So how many clusters we want to generate, and how many attempts. So means that how many times the iteration will take place, and it is giving us a value. So first we will look for the by default value, and then we will make some changes. So let's run it. So over here, we will see that this one is our original image, and so it is getting segmented into 3 clusters. So 3 clusters will be formed. Now let's change that particular cluster k value, just like as a type 5, and we want to change the number of attempts will be 15, and figure size now is a and change the figure size also, just like we want to change the figure size, and then we can okay. So it is giving us so the 5 clusters will be generated. So this one is a basic demo, very but if we will, this is a hurt image, but if I run this same sheet on a different image. So let's suppose I have an image of tissue.jpg. So when I'm showing error, 1 second. So extension would be jpg. So we have so we have to use this jpg. So we have to run this whole sheet again. Then we will, okay, so this is the tissue image. So over here we will see the difference that that particular hurt image is not able to give us. So when we convert into RGB to grayscale, so it is getting converted. Okay, so our image is getting converted to RGB to grayscale, and then it is getting the printed of that particular shapes. So we have a 1067 into 1600 size. So this is the shape of our image. Then we will to perform the same analysis. I think yes, it will not work for so this line of is not work for that particular tissue segmentation. So we will detect over here. We will perform the. I think you have to change. Your image is converted into grayscale. So it will depend on the image to image that whether you are getting much more information or not. So over here we are getting some lines are available over here. So we can use that particular code for our research work. Then print that grayscale. And then if we perform image segmentation, then we will use tissue. And our image is getting loaded up. So actually, this image size is much more larger. So over here, see, so we are making a 5 different clusters on that particular image. So in this way, we can perform the analysis and these small codes. If we use Python GUI based interface, then we can make a tool out of it. Or it will depend on the research that in which domain we are working. So for particular image, we can make a similar tool. Then comes to the third disease, that how to run the CNN and CNN architecture and how the pickle will work and how the model will work. So on that particular data set, on the MNIST data set, I have dictated that how the images will look like and how your machine learning model will work on your real-time data set. So so similarly, we will perform similar type of analysis we will perform over here. So one second, let me, yes, so this sheet I have to use. So this is a save pickle demo, which will be used to parse the values, which will be used for the online applications for develop a mobile based application or for the web based interface. So we will use a pickle. So what we will do, we will create a machine learning model over here, and this one is the simplest machine learning model which will perform nothing and it has a less accuracy. And so we will import the all the libraries, which is NumPy, Matplotlib, OS, and CV2, and then comes to the part over here, loading of our data set. So what we will do, we will load our data set from our own machines. So I have a data set is available over here. So I have provided that particular data data set on folder. So when you run that particular sheet on your own machine, so over here as you can see that I have divided that particular data set into two folders, so hyper and normal. So what is happening over here, we will give the path. So we will give the path over here. So I have a data in the D drive, and then it's in a categories. So what are the categories? So I have only two categories. So if let's suppose we have three categories, then we can work over here and we can add 4 categories, 5 categories. So it will depend on our requirement. If we have a problem where we have a more than one categorical data, over here we will performing a binary classification, whether it is a 0 or it is a 1. So whether a person is active with heart disease or not. So over here we have a multiple categories also. And then one second. So earlier, so we are working on this cats and dogs. So we are going to build up. So, but so what we will do, we will divide this into hyper and normal, and we will run a loop over here, which will iterate this all the values into that particular loop, and then we will join that all the images in an array, and then this particular line of code will give us a image. So over here it is showing us that image dot read, and then it is joining that particular path, and then it is converted into grayscale within an array, and then it is giving us the image. Then we will print the array, and it is showing us the this size of that particular image in an array. And then we will print the shapes. So it is showing that 156 and 192, and then we will print the size. So in the last, uh, yesterday I have dictated that we can use different sizes of image. So we can change over here 100 or 100 or 50 or 120 or 200. So it will depend on your requirement and your computational power also. So I have a 60 GB of data, which is a 50 size. So if I've changed up to 100 and 200, then now you can imagine that how much data would be available over here. So it is getting 100 GB, 200 GB. So your image size, if we increase a little bit over here, 10 or 15, then your image enhancement will be work out over here, and then it is getting a different just like as it is showing us a 40, that's changes to 200. So if we look available over here, so it is getting changed. Your size of image gets changed, and it is getting the size is getting heavier. So we have to stick to, depend on our requirement and our computing power. We have to stick into these resources. So we can stick to 50 cross 50. So it is showing us over here, if less information is available over here. If we look into 200, then it is giving us a much more information. If we look, let's take 500. So it is much more enhanced way. So it is giving us much more information. But for this demo part, we will stick to the 50 only. Now we will convert to gray. Okay, so it is not giving us any change over here. So now we have to load our data. Okay, so this line of code will loading our data for the training purposes. And over here I have thousands of images, so it is showing conversion to grayscale, and then we will use that similar array. So it is I have commented all this code to for each line of code. So our data is getting loaded up. So we have a now we have a 32,000 of images, 30,000 of images. So it will take some time. So over here I have 1,000 images, which is of 50 cross 50 size. So it is done within a few seconds. Then we will print the length of our training data. So we have a length of 2086 of our total data samples, 2000 approximately. And then we will train our data over here. So it is giving us a sample. So it is a 010101 format. And then we will look for the features labels. What are the values that are contained within X and Y that we have trained our data. And then we will append these values also. And then we will use pickle to store these values. Okay, so we will use that there is a library called as import.pickle. So over here we will save our values. So first of all, we have to open that X values and Y values, and then we have to save that also. So over here our values get saved up. So over here these values are this will generate a x and y. So in this way, our values are getting stored up. We are not able to read, but in this way, the pickle value will be stored, and these values will be passed on that particular backend, which will work on our mobile development application when we build up our model, and it will classify at a real-time scenario. So we will use these values to parse our data from there to the front end, whether it is a GUI based interface, whether it is a mobile based applications. So we will use this pickle. So this lab sheet will help you out to do a basic analysis and how the pickle and how the all the things will work. Now, so this one sheet will show you out that how you are building up your machine learning model for the heart disease. So I have taken the example of heart. You can imagine on your own type of research which you are doing related to biomedical, related to agriculture, related to any domain. So let me clear that first. So over here, what we have done, we have imported the TensorFlow libraries, and we have imported the TensorFlow library, then NumPy, then Matplotlib, OSCV2. These are the basic ones which are need to. Then we will import some another libraries which are needed to build up our convolutional neural network as as I am running the CNN, and if we are dealing with the RNN network or LSTM or other type of network, then there are some another libraries which needs to be imported. So same analysis which I have performed earlier, but there is a little bit difference which I will show you. So we will load our data for the training purposes. Then we will print the length of our data. So over here we will randomize our data, means shuffle our data. So what does it mean that we have images available over here? So these are the positive images, which are the person is affected with the disease, and these are the negative images, like as a normal person which do not have a heart disease. So, so when we load our data to run a machine learning model or to make a deep learning model, so so it is getting first of all the thing is that first of all the images which are positive, and then first then we have a negative images or a normal images. So this function will randomize our data samples. So now we don't know that these are the images for the positive, these are the images for negative, the person is having a heart disease or not. So and so all the image will be randomized to this particular line of code. Now we will enter into that training data part. So we will add available over here samples. Then we will save these values pickle, which will be used to convert to pass the data, and the model will be used. So over here we are building up our convolutional neural network architecture. So we are using model.sequential, and we are adding two layers available over here, and then uh, uh, we are so over here it's a two layer or three layer architecture. Then two layer architecture, we can add more layers available over here, and then we will use the activation function sigmoid. So it will depend on the literature that that whether we have to use over here that sigmoid or ReLU, but there is a little bit difference from this ReLU and sigmoid. So over here we will paste it by default. We will run the epoch size, and batch size would be 32, and epochs would be 5, and validation split will be 0.3. So that means that our data would be split based on uh, based on value. That is 30% data would be used for the split to test our machine learning model, and 70% is used for the training purpose. I'm sorry. we can change the batch size over here also. 64 we can use 128. So generally uh, people will use, the research community will use 64, the batch of 64 will use. So we are getting our model trained up over here. So while running this ebook, so for to run a good model, at least you should run 100 epochs so that you can get a lot and accuracy. Over here, we are getting a good accuracy, but uh, it has no of no use, and it is sort of demo purpose only. Then we will use that model hard disease model dot save, and then we will use to predict the values of our model. So it is getting the values from that particular model, and it is getting our predictions done. So this is showing us a 37% accuracy. So the model which I have trained right now is showing us a 37% of accuracy. Over here, it is getting accuracy of validation accuracy is 71%, but at the time of prediction, so we can say that it is not a good model. So we have to just make the few changes available in that particular sheets, and then we can build up a good model with the help of this particular uh, lab sheet, particular demo sheet. So our model will be saved over here. Hard disease prediction. Okay, save equal dam. Hard disease predictions. Next workshop. Hard disease model. Okay, available over here. So when we can build up different model. Hard disease model 1, and then underscore 1, and then we can save it. And I think it is getting some error. Okay, we have to build up our model again. So we can save our model underscore 1. So it is our model is getting saved, and then it is giving us the same. Let's change the epochs, number of epochs, and we will see the results in the, just like a change the validation split also. We will see the change in the accuracy. So our accuracy would be changed. So in this way, we have to change and we have to make different changes depending on our own requirement. And you can pursue our research in biomedical domain or in any related to the image processing, and we can run our deep learning model on the image part. We have data related to numeric data also, but if we have a direct images, access to direct image, then it would be beneficial for us because we will get a much more enhanced information and it is getting a refined information. So let's see what our model will accuracy will be. We will perform. So we will save our model with 2, 2, and it is giving us a different accuracy. So now our batch size has been changed, and we are getting our accuracy has reduced again. So in this way, you have to build up different model, and the model which will give us a good accuracy, we will use for that for the later on purposes for to build up of our machine learning model. So that is my part of that particular demo. So in this way, we will make up our machine learning model. So I think I have completed segmentations. I think I have completed all the sheets, and I have dictated the how to build up a machine learning model demo. So in the tomorrow the Aman sir will be demonstrating to you people that how to parse this model to Android based applications and that how to perform that and how to run that analysis also. So thank you. So now I will open for the doubt clearing session. So if someone has any doubt, then you can ask.
Audible, audible.
Oh, okay, thank you, sir. So, sir, I have dictated the sheets which I have presented right now, but we have some times. I think my session is completed earlier as the time allocated to me, or I think I have dictated much more faster way. Uh, so I have created this much of sheets. So now I will open to the questions. Yes, I think someone has raised hand, so I can answer the questions. If someone has any like how to load the data and how to build up a machine learning model.
Anyone having any doubt, please raise your hand. Sir will give you proper answer.
This model on related to the brain tumor also. So similar type of model will work. Actually, I have talked with sir, so he has told me that we can work on the brain related data. So similar type of model will work on the brain related data. Actually, I don't have data right now related to the brain imaging, but yes, we will look into the some data if we have got the data from the UCL or that there is the web repository brain imaging. So NBRC. So if we get some data from here also, then